Yeah, so hopefully you're multitasking a bit. That's an application you could potentially play with, and then we'll see a live tracing of that application. So the topic of my talk today is cloud scale application monitoring. So as part of VMware, we have acquired a number of cloud native solutions. And the product we're mentioning or actually utilizing here is a product called Wavefront. And I'm an application platform architect. I joined VMware about a year ago. So today we're really going to be focusing about how do we run large-scale applications on cloud. So just show of hands, if possible, how many of you heard of the term SRE, Site Reliability Engineering? How many of you are a SRE? Okay. Awesome. One. How about how about you monitor? Anyone here that monitors your applications on production? Okay, awesome. Okay, so today, squarely, we're going to be talking about how we at Wavefront, how at VMware, thinking about running in production. So, as all software engineers, we write code. And the purpose of writing code is not to hang up on the wall. It's actually to run in production. It's actually to generate business value. That's the sole purpose of why we write program, we write code. And we're only realizing the business value of our software when it's actually in production. So, so that's the talk of the today. So how do we actually, how do we go to production fast and potentially having that scale of the application running in multi-tenant, cross-continent, large-scale cloud applications. So before I get into the real details, there is a number of secrets I want to share with you. So the first one is, this set of secrets really underpins the application monitoring and then the concept of observability. So anybody heard of observability? Awesome, okay. So the only thing that matters is really the customer happiness. So that is the evolving things of where we as a team at Wavefront is really targeted and centered around making our decisions. And the second secret I'm going to share with you is the 9s don't matter. You heard about people talking about 3 9s, 4 9s, 5 9s, SLAs, SLIs. But we also know that we are able to, and the third secret is the mean time to what happened is really that matters. It's not really the mean time to resolution, it's really the mean time to find out where the problem is. It's not really about, so the earlier you find out where your bottleneck is, the earlier you find out where your bottleneck is, you're able to really defeat the purpose, in terms of really the physics. Potentially, you can have a 5-9 applications running on 3-9 infrastructure. It's only if and only if you're able to debug in time, and also you're able to find out the bottleneck very, very quickly. So we'll be going through and telling you about how we're actually achieving that. There is a philosophy that we really hold close to our hearts, and actually in the back of my jacket, it's the concept of beat jobs. The beat job is a lot of things encapsulating in that concept is really, we want to be lazy. It's really about how do we build for lazy. And it's really about how do we leveraging tools, how do we leveraging computers and machines to do more work, and then so we can spend more time at beach. You see, as the industry progresses, right, we have solved the problems of ingesting data. We potentially have also solved the problem of storing data. The really hard part is about how do we make sense of the data. You have a lot of monitors out there. I mean, every infrastructure or even application team, potentially you have something for networking, something for database, something for storage, and you have tracing going on, application tracing. But how do you actually making sense of everything that you collect? Or do you go around asking, is the network fine? Is the database fine when something goes wrong? So it's really about the hard stuff is how can we make sense of our data for quick debugging. So we have this concept of 3D observability. And just to give you a sense of the scale that we are running on, we have a bit beyond 5,000 services running on cloud. And we're ingesting around 130 billion data points per day. And we have 2 SREs running the whole production system. That is a concept of big jobs really at work. And we're really utilizing tools, we're really utilizing machines to really work less, if possible. And these 2 SREs is only recently, we had one for a number of years, but with the VMware acquisitions, we need to have 2 and potentially taking on more workloads. So yes, this is the concept that baked into our philosophy. So the 3D observability contains 3 components. Those are the fundamental building blocks. The first one is metrics. So what are metrics? Potentially metrics are a series of CPUs requests. It's a value and it's a timestamp. It's some optional tags you can tag into the end. Right? It's something that you monitor through a period of time. And what we want to do with metric is something that we can quickly aggregate. We can do calculation on them, we can compute them. It's not just a text file, right? It's something that's live, we can actually work on them. The second building block to all this is really the histogram. So histogram, as you may be aware, we use histogram to do a sense of aggregation. Right? So I won't say it's really metrics incorporating with percentiles, data with percentiles. So in here, we can really understand the performance of our customers. So because we are a running multi-tenant, have all our customers on different clouds, we want to know how much of our customers affected with potentially a system down or something, a slow response. How many of customers are affected, where are they, and which one of them potentially want to pinpoint those. And this is a very fundamental metrics that we use, histogram, to actually allow us to capture that and to actually understand the impact of the down, the system down potentially, or the response. Okay, this is just a visualization. If you're not familiar with histograms, it's really about aggregation. So we understand the maximum percentiles, the 99 percentiles, the 95 percentiles, basically where we customer, their potential experience of the system. And because of this, we really like to pinpoint down, potentially even get to the 77.7% percentile. We can even get to the very pinpoint of customers who are actually experiencing the problem. So the last bit of the building block that we use is tracing. So tracing, you probably heard of a lot of tracing products out there. This is talking about application tracing. How we profile, how we monitor our applications. So this is a really critical part where we pinpoint in the application where the failure comes from or where the poor performance comes from. So this is tracing in terms of this is really about a gauge of the application that we have and really understanding the span that each methods, each core is spent on each of the, from the services to the components, etc. So span is really the primary building block of a trace. So these are the fundamentals of where we use as a team to really help us to really understand. Those are the building blocks for how we perform and do our job as a production engineering running on cloud scale applications. So, and just give you an example of traces, we literally broken down the cores from your services down to your components, down to each methods, and then we're able to pinpoint a length of the core and also pinpoint the critical points, how long we spend on that methods. So this is a summary of the metrics, histogram, and tracing. So these are the things how we're using these techniques to really correlate application metrics versus infrastructure metrics to help us really quickly pinpoint where the problem is or where the performance issues are. So in the earlier of the presentation, I showed an application called ordering a shirt. So if you actually jumping onto it, you'll probably see a slide like this, or potentially see a screenshot like this. Or if you're lucky, you might get an error message. Right, so this particular application is really a microservice, a polyglot microservice. It has been built with many different languages, many different libraries and frameworks. I was not trying to make the life complicated, but this is just to show that potentially this is the world that we're going into. Potentially this is the way that we're going to be operating. Right. As we all know, we're moving away from, or we're potentially still maintaining monolithic applications. Then we have NT applications. Then we have SOAs. And then now more and more is moving into potentially microservices. And with these microservices, people are building them in different languages. We need to have services, manage them. Manageability becomes a difficulty. And actually finding out where went wrong become very challenging problems as well. Whereas monolithic, everything is a core, a memory core within a domain that you understand. Whereas microservices, potentially they're spread out across multiple cloud instances, and then the latencies, the performance issue, the impact, that it is something that needs to be tackled. So how do you solve that problem? So potentially you are a developer building a set of applications, and your choice might be using, Python, Ruby, and you've done your testing, you've done your dev testing, you've done your, potentially integrations, you have done your all sorts of tests that you need. Okay, I think it's working, so let's check them out to the SREs on call. So there's on-call SREs, right? So, but having the SREs on call, I have no knowledge of what this application does or what the component you just built. How am I supposed to service, manage, and operate this when something goes wrong? Right, so this is the challenge. So we mentioned about BJobs. Just give you a few examples, potentially how BJobs can go wrong. Now, one of them is you don't know where to start. When a problem comes in, something fails, you get the alarm, you have no idea where to start. Where do you go as an on-call SRE, 2 o'clock in the morning? Where do you go start? Okay, potentially you have seen the order share API that we just presented. What is the request call flow? Who's got touched? What are the relationships? What are the service dependencies? Who else is impacted? Yesterday we have a great presentation talking about root causes. How many of that's impacted? You have no idea, right? And then we don't know. Those root causes we're talking about, even if we identify them, we have no idea what the health of other services potentially could degrade into a problem, right? And then we're having how many of the customers actually having these issues, right? For us, this is a very important metrics we want to know, like what is the blast radius of this impact? Who's impacted? What are the medians, the P90s, the P99, of our latencies? How slow? What's the performance? Because we really care about customer experience, right? And then, we cannot identify, we cannot isolate the bottlenecks of the issues and what actually causing this problem. And then we have no way to even diagnostic or actually getting in a start to remediate. So these are some of the, the things that the people on call, some of your SRE engineers, potentially your operation engineers might be experiencing. When something goes wrong, they have no idea where to start. And where do we go to look for help? All right, so now you might look like this. They might be on call, and they're looking like this, very stressed, and they start digging logs. Right, so we have log file, we're digging through log file to see if we can find something that's there. Potentially, if you're utilizing BJobs, how you're doing it right is if we're using the metrics, histograms, and traces in combination. And very likely you'll be looking like this while you're having a problem, having a cup of coffee, and actually understand where to start. Right? So you have a dashboard that shows you application level tracing. So this application level tracing, it tells you where exactly, which methods having the highest latency, having the, potentially having the error logs, error generation, highest errors. And we're also potentially going down to the red metrics. So red metrics are something the SRE hold by heart. It stands for the requests, the error rate, and also the duration. Those are the metrics that every SRE will check when something goes wrong. A method, how long, how much requests, what's the duration, what's the error rate. So they're going and having the tools and having the metrics to help them look deeper into the issues. And they would like to understand, okay, what is the relationship? Understanding how each service mapped out and actually traces the dependency of each services. And our SREs on call, we use a lot of maths and we use a lot of science, which you see where the problem is. So this is an indication of the metrics that we're collecting. This is a generating and some potential queries we run on set of the metrics that we collect. And we also construct complex alerts. Alerts or monitors, however you want to call them, we want to make sure in terms of holding the BJobs concept is we don't want to be wake up at 2 o'clock at night. If we do, it better be something that's critical and never seen before. If we have seen before, we will be engineering away those alarms or engineering away those monitors. So we shouldn't be reacting to the same problem twice. It should be resolved and engineered by computers. So we write queries to actually engineer away the alerts that we're experiencing. And we build charts to really explore our systems, actually dynamically, actively, proactively finding out where could be the problem is. Rather than things really land on our feet, we're actually looking for problems. And we use techniques to really identify the anomalies before it happens become a problem, right? So we use anomaly detection to really find out where the problem potentially is. At the end, that's a comparison of where you might feel like before to where you having the BJobs or concept embedded and become part of your operating environment. So this is just to summarize the talk. The 3 building blocks we utilize in VMware and Wavefront is really the metrics, the histogram, and the tracings. So these are the fundamentals where we actually help us to get to the details, to pinpoint the bottlenecks of the problems. The next one I would just like to share in terms of the philosophies and we really live by is we prepare our infrastructure with the application context. So we don't have a separate team. We do core rotations. We have engineers from application teams working doing the rotations. Get them to experience what does operating means. So this will inject the mindset is, the mindset is really how do I build my applications with more production ready. So getting them to see what the scale of the operations look like. So that's very beneficial. But however, we also need to do that is application and infrastructure metrics need to be correlated. They need to understand. So your application sitting on a set of infrastructure, we need to know what application we're serving, right? So what domain, what application serving. These are the preparation work that we need to go put into before we're able to do the analytics, the science, the data pooling, the correlation we use in the tools that we have. We'll prepare our infrastructure to really have the contextual meaning of the application running on it. The next one is we don't really segregate or calling us infrastructure engineers or software engineer. We're all engineers. We are writing software, writing code to solve either an infrastructure problem or a potential business problem. So we are all engineers at the end, software engineers. So in a team, we don't really delineating that. The other thing is, as I mentioned before, we really hold this mantra to heart is the only thing that matters is customer happiness. We get challenged all the time, so why aren't you delivering 5 nice services? Or why aren't you delivering 4 nice services? You should improve your SLAs. But sometimes you have the best SLA, even the most 5 nines, you might not have the most happy customers in here. So that's really concludes my talk, how we run production scale cloud application.